Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to parallel lines. Now, many of you might have experienced parallel lines, say, when you're dealing with a train track or something to that effect. You think of that, and you know that if the rails get off even by a little bit, if they start coming together too much, then the train wheels aren't going to fit in there and it causes problems. So when we talk parallel lines, we really are encouraging them to not meet at all. So they have to stay equal distance apart for all spots. So again, parallel lines, we usually use two symbols like this. A lot of times we see it slanted, but this distance across must stay consistent the entire time. So what we're especially going to look at is what happens when you take two parallel lines, and they're usually going to put arrows on them to indicate that they're parallel, and you're going to cut them with a transversal. So this is a transversal, and I did not put arrows on them, but to just keep the image a little bit cleaner. So transversal is any line that cuts across your parallel lines. Okay, so this is going to cause a lot of information to happen, okay? We have so many relationships that are caught here that it takes a little while to explain them all. So let's just look at, if I number these 1, 2, 3, 4. What you'll notice off the bat is that angle 1 is going to be congruent to angle 3. If you've watched some of my previous videos, you'll understand why. It's that if I turn them like this, we can see that they're vertical angles. They're straight up and down from each other, right? That's not the only pair of vertical angles that we have. Angle 2 is congruent to angle 4, again, because of vertical angles. So let's go ahead and let's keep numbering 5, 6, 7, 8. So angle 5 is congruent to angle 8, and angle 7 is congruent to angle 6, all due to the fact of vertical angles. Okay, so we've had a ton of vertical angles coming in there. Now, vertical angles are not the only thing that we've got going on here. We also have what's called corresponding angles. If you notice, angle 1 and angle 5 are above the vertical line and to the left of the transversal. They are in corresponding locations. And because of the parallel nature, that transversal is going to cross through one in the same way as it crosses through the other. So because of corresponding locations, we have corresponding angles that are congruent. So angle 1 is congruent to angle 5. Okay. Do we have other corresponding angles? Absolutely. 2 in the top line and 6 in the bottom line are also corresponding. And so on and so forth. So we have 3 and 8, and we have 4 and 7. Okay, well, here I said 1 is congruent to 3, but here I said 3 is congruent to 8. So that must mean 1 and 8 are also going to be congruent. And that's true. So if you'll notice, 1 and 8 are on opposite sides of that vertical line. Okay? So we have our vertical line here. 1 and 8 are on opposite sides. Then you might also notice, there's that, right? I'm going to go ahead and highlight this. I'm highlighting the inside of the parallel lines. Okay? Everything between the parallel lines I'm going to call interior. Everything outside of it I'm going to call exterior. And of course our parallel line is right here. So 1 and 8 are on opposite sides, also known as alternating sides, and they're outside or exterior, kind of like interior paint, exterior paint. So we have alternate exterior. And now we know that angle 1 is congruent to angle 8. Okay, is that the only alternate exterior? No. 2 and 7 are also, which makes sense because 2 is the same as 4 and 4 is in the same position as 7. So, okay, there we go. By that saying, 1 was congruent to 3 and 1 was congruent to 5, which means 3 and 5 must be congruent. And they're on the alternate side of the transversal, but they're inside. And that's exactly what we've got there, is alternate interior angles. And that would be angle 3 is congruent to angle 5, and angle 4 is congruent to angle 6. So we said 1 is congruent to 8, 1 is congruent to 3, 8 is congruent to 5, 5 is congruent to 3. Okay, so all 4 of those angles that have a dot are the same exact size, which means the 4 without a dot, are they also the exact same size? Absolutely. So I'm going to redraw, now that we've talked about all the congruent sides, we've got half of them are one size, half of them are the other size. We're going to go ahead and compare, and I might number them differently this time. I don't know. So I'm going to draw it different, just parallel lines, cut by our transversal, 1, 2, 3, 4, 5, 6, 7, 8. And this time I want to go ahead and look at something a little different. What do we know about angle 1 plus angle 2? Well, if you notice, angle 1 and angle 2 are a linear pair. Together they make a line, right? So they add to 180. We also know that angle 1 and angle 3 add to 180. Okay, because they're also a linear pair. The same thing with measure of angle 3 and angle 4, right? We could do 3 and 4, we could do 2 and 4. We have the linear pairs for this part, right? But we said this angle right here is congruent to its alternate exterior. So I can substitute the measure of angle 8 for the measure of angle 1. Now look at that. Now let's think about how 2 and 8 compare. 2 is on the outside, and 8 is also on the outside. So they're on the same side, but they're outside. So same side exterior. Add to 180. Okay. What about same side interior? Right? We said above that angle 2 is congruent to angle 6. And we said angle 1 is congruent to angle 4. 2 and 6 because they're corresponding. 1 and 4 because they're vertical. If I were to substitute 6 for 2 and 4 for 1, measure of angle 4 plus measure of angle 6. Still 180. So same side exterior is 180 degrees, but so is same side interior. I found this really, really cool image. It says copyright scaffold math and science. Found it on the internet one day. Actually, I think I found it Facebook. Okay. Everything that's shaded dark or if it's dark, it's a corresponding angle, right? So if it's colored in, so it looks like that. The ones with stars are alternate exterior, so we can see alternate exterior. Okay, we can also see the shading for corresponding. Okay, if it has slashes, it's an example of vertical. If it has dots, it's same side interior. And here we notice that that says it's adding up to 180. Okay, alternate interior, that's the other shaded. That would be these. Those are congruent. Same side exterior, that would be the blank. That would be this one here and this one here. Add to 180. So it's safe to say that if you're looking at parallel lines cut by a transversal and you're talking about two angles, you're going to have two options. They're either going to be congruent or they're going to be supplementary. No other option. There's a lot of relationships here, and this image is just kind of a quick little fun synopsis of kind of color coding it. So the only ones that add to 180 in this picture besides linear pairs, but for the parallel lines specific, because linear pairs can be done without parallel lines, are same side interior or same side exterior, which is just a blank arc right there. So that's why you don't see it colored in. It's because they wanted to use that for a key. So scaffold math, I think I actually found it one day on Facebook, but I thought it was a really nice image. So here we have an image of two parallel lines as indicated by the pink arrows. And they've given us one angle and they want us to find the remaining 7. So 1, 2, 3, 4 was given, 5, 6, 7, and 8. Okay, so how does angle 4 compare to angle 1? If you said they were vertical angles, you would be correct. So they're equal because of vertical angles. So that means 1 is also 118. Now how does 4 compare to 8? Okay, 4 is in the bottom right hand corner, 8 is in the bottom right corner. So the measure of angle 4 is going to be equal to the measure of angle 8, and that's because they're in the same location or corresponding locations. Oops, I forgot my degree sign on that 118. So this is also 118. Okay, now how does angle 4 compare to angle 5? Well, if you said they were alternate interior, you would have been correct, which makes them the same size. So alternate interior. And so 5 is also 118 degrees. Okay, now how do 3 and 4 compare? If you said they're a linear pair, you're correct. Measure of angle 3 plus the measure of angle 4 equals 180 because they're a linear pair. So if you do some subtracting, you're going to find out that that leaves 62 degrees over to be angle 3. Well, 4 and 7 are same side interior. So 4 and 7 also have to be 180. Whoops, transpose those numbers because the same side interior, making angle 7 also 62 degrees. If you said 4 and 2 were a linear pair, you'd be correct. Again, another linear pair. So that means angle 2 is also 62 degrees. The only one we don't have a vocab word for is angle 4 versus angle 6. However, we know that 6 is the same size as 2, and we just said 2 is 62. So by the transitive property, by saying, hey, this is the same as this, and this, we can actually kind of do substitution as well. We also find out it's 62 degrees. So half the angles were 119, half the angles were 62. So that's what we really need to know, is that they're either going to be adding to 180 or they're going to be the same size. When you have parallel lines cut by a transversal, that's all we're going to see. Okay, you blinked and an entire new picture showed up on my screen. If I were you, I would go ahead, if you need to, and pause, and that way you have time to write all this down. There's a lot of information to unpack here. Basically, there's an image, points A through J, and they want us to find 3 angles. And then there's a lot of red marks. So let's just take the first one. It says that this right here is parallel to this right here. Okay, and I've not done my best job of drawing it, so keep that in mind. But these are parallel. And they are cut by this transversal right here. Okay, so we can see that 115 is below my pen and on the right side of my highlighter, and angle 2 is below my pen on the right side of my highlighter, which tells me they are in corresponding locations because they're both on the bottom right. And if that helps, what you can do is you can just draw AB and it looks like IJE. And we see that we've got this line coming from A going to, I guess I would have been right here at this. I kind of extended it out. And then it comes through H, right? And they put 115 here. So when I look at extending it, and I'll just go ahead and come up here. I'm extending it, right? So we can see better the 2 lines cut by a transversal. We can see that this is on the bottom right, this is at the bottom right, so they're corresponding. So therefore, the measure of angle 2 has to be 115 degrees. Okay, so what I recommend in the classroom, if you need to, it's kind of this old school thing. It's called a transparency. You can also use a page protector, but if you do it and you have any dry erase Crayolas, markers, whatever, you can get them, and then you can highlight images. Sometimes I think the highlighting of images makes things better. Okay, so we used the 1 mark here. So now I'm going to highlight the 2 mark. So here's parallel lines, and they're cut by several transversals, but we don't have anything that we're talking about on those, so I'm going to skip those and I'm going to go to the 3. Okay. Now I see something. I don't know if you saw it. What if I focus in on these 3 pieces? The parallel lines, the pen, I'll make those both pens. So the pens are parallel, assuming I can draw. And the pencil comes in, and it's our transversal. Well, we can see angle 1 and angle 115 are on the same side of the pencil, so they're same side, and they're also inside of the pens, so they're same side interior angles. Those are not congruent. In fact, we can tell one's acute and one's obtuse, which means that they must add to 180. So I can come in here and I can do 180 minus 115. And I can find out that angle 1 must be 65 degrees. Again, that was same side interior, right? This one we found because they were corresponding. Okay, so angle 3. angle 3 is between these two, which is the one with 3 dashes and the one not. So I'm going to highlight that one just so we can really see, since it's my last one to do. The other one with 3 dashes are here, and there's a couple of them that are connecting them. Wow, those are really bad parallel lines. But since angle 3 comes using this side, I'm going to draw it. Well, what do you notice about angle 2 versus angle 3? I notice the angle 2 is below the parallel line on the down part of the transversal, and angle 3 is in the same position. So again, we have our parallel lines. Should always do 2 pins for that. The lines are parallel. Try to make it where we can see everything. So we have our parallel lines that are poorly drawn. And we have our transversal, and we can see that 2 and 3 are both below the pencil, and they're in the same location because they're below the pen. So that means they're corresponding angles, which means 2 and 3 are the same size, meaning that we're at 115 degrees again. So just make sure that you always are comparing 2 lines. When there's something like this and there's a lot of extra, you can go ahead and you can kind of highlight out some of the extra stuff. Even if it means taking something as simple as like your plastic from, and this is actually from holding paper, and using it so you can highlight. That way it can be erased, because I know you can't write in your textbooks or whatever. Again, I like using transparencies. If you have an old binder, the ones that have sleeve covers on the front where you could slide a piece of paper into your 3-ring binder, if it's falling apart anyways, pull that off and use that for something to highlight over. It works great. Anything that's see-through and plasticky, you can use your dry erase markers on. I like using Crayolas because they don't dry out. You can get those at Walmart, wherever, Target, Amazon. They're not very bright, so you can't like see them across the classroom on a board, but they're great for at home or, but again, make sure you're writing it on a surface that you can erase. If you're worried about erasing it, test a small spot first. Make sure it's yours. Don't write on your paper because it does not come off your paper, but really make sure you're highlighting the bare minimum so that you can compare apples to apples. Make sure you have a vocab word that would support your choice. And that's always a big thing, is making sure you have that vocab word.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.